All right, welcome to our next section. This section, we're going to introduce us to quadratics. And really and truly, you've been working with quadratics most of last week. You just didn't necessarily know that's what it's called. A quadratic is a polynomial with one variable that has a highest exponent of squared. So standard form for a quadratic is ax squared plus bx plus c. Notice a is with x squared, b is with x, and c is by itself. They're always there, a, b, c. A quadratic, when we graph it, creates a U shape like this, and it's called a parabola. Not parabola, parabola. Now there's two different types of parabolas. You can pull out your nifty-difty graphing calculator, if you have one, or you can just trust me that this looks something like this. Notice that A is positive and it looks like this. If I go to my next one, A is negative, and again, you can pull out your trusty calculator, but it's going to look something kind of like this. Maybe they're not in those exact locations, but they're the similar shape. So the two different types of parabolas come from that A that's in front of x squared. If A is positive, then the parabola opens up. If A is negative, then the parabola opens down. Think about it like a smiley face. If you have a positive day, you're going to smile. If you have a negative day, you're going to frown. Next is our axis of symmetry. So a U you can cut straight in half, right? I mean, if I had actually put that line in the right spot, that U would be in half. The axis of symmetry is the line that cuts the parabola in half. And we actually have a way to calculate that from the equation. Our axis of symmetry, we're going to say is x equals negative b, or the opposite of b, over 2 times a. Next, we have the vertex. It is the most extreme point, or the turning point. Also good to know, lands on axis of symmetry. When my vertex is the lowest point, we call it a minimum. And when it's the highest point, we call it a maximum. All right, so today, in this section of notes, we're going to look at a quadratic formula, we're going to find the axis of symmetry of the vertex, and we're just going to decide whether or not it opens up and down for our up or down for our sketch. But before we start all of that, we should decide what a, b, and c is. Remember, x squared has the 1 out in front, so a is equal to 1. B is with x, so B is 8, And C is all lonely. C is 15. Start at the axis of symmetry. We know x is equal to negative b, or the opposite of b, over 2a. So I need a negative 8 over 2 times 1. Well, 2 times 1 is 2. And negative 8 divided by 2 tells me that my axis of symmetry is at x equals negative 4. Vertex. Well, we know it's our highest or lowest point, but go back to your definition. I told you the vertex lands on the x-axis. So the vertex is a point, so it's going to have an x and a y, and the x is always the axis of symmetry. So in this case, my x is negative 4. And to find y, I'm going to plug it into my equation. So I'm going to take this negative 4 that I just calculated and plug it in for the x values of my equation. So negative 4 squared plus 8 times negative 4 plus 15. Negative 4 times negative 4 gives me a positive 16. 8 times negative 4 is a minus 32. And then add 15. 16 plus 15, that's 31. Minus my 32. So I have a negative 1. The y value for my vertex is negative 1. And then our last job, we need to decide whether or not this opens up or down. So go look at your a value. Is a positive or negative? Well, it's positive, so it's going to be a smiley face. I know this point right here is my vertex, which is negative 4, negative 1. I know my axis of symmetry goes straight down that point at the line x equals negative 4. All right, let's do another example. Let's do that all over again. Number 2. A is in front of x squared. In this case, a is negative 1. B is in front of x. B is 10. And C is by itself, a negative 23. Notice how I took all of the signs with me. I took this subtraction sign from the 23 to make it negative. Took the negative in front of the x squared. That goes with my a as well. All right, axis of symmetry. X equals negative b over 2a. Negative b, negative 10 over 2 times negative 1. So negative 10 over negative 2. Negative 10 divided by negative 2, that gives me a positive 5. My axis of symmetry is a positive 5. Vertex is an ordered pair. The x comes from right here at my axis of symmetry. And then I have to plug that into my equation to get my y. So I have a negative 5 squared plus 10 times 5 minus 23. Notice I put the negative that was in front of my x squared outside of my parentheses. So I need 5 squared, which is 25, times the negative out front, so a negative 25. plus 10 times 5 is 50, minus 23. Negative 25 plus 50 is 25, minus 23. 25 minus 23 is 2. And then last but not least, decide whether or not we're smiling or frowning. Is A positive or negative? It's negative. You're having a really bad day. And apparently my settings are going to try and open. It's negative. You're having an awful day, so you're going to frown. And I know that highest point is 5.2. And I know that that is where my axis of symmetry goes through. Let's do another one. All right, A equals 3, because it's with x squared. B is negative 12, because it's with x. C is 5. Axis of symmetry, x equals negative b over 2a. Negative b is a negative, negative 12 over 2 times 3. Negative negative makes a positive 12, and 2 times 3 is 6. 12 divided by 6 is 2. X equals 2 for my axis of symmetry. Vertex. I get my 2 for my axis of symmetry, and to find the y, I plug 2 in. So I have 3 times 2 squared minus 12 times 2 plus 5. When you're calculating, do not forget your order of operations. Please excuse my dear Aunt Sally. Square that 2 first. So I have 3 times 4 minus 12 times 2 plus 5. 3 times 4 is 12 minus 24 plus 5. Negative 12 plus 5. And negative 12 plus 5 equals a lovely negative 7. So my y is a negative 7. And then last but not least, decide whether or not we're smiling or frowning today. A is positive. When we have a positive day, we smile. My vertex was at 2, negative 7, and my axis of symmetry goes right through that point. Let's see if I can get one more in this video so that you have one more example. A is 4, B is 8, C is negative 1. Axis of symmetry, negative b over 2a. So I have a negative 8 over 2 times 4. Negative 8 over 8 equals a negative 1. So my axis of symmetry, x equals a negative 1. Which means for my vertex, the x is negative 1, and I have to plug it back in to find the y. So 4 times negative 1 squared plus 8 times negative 1 minus 1. Square first. Negative 1 times negative 1 is a positive 1. 4 times 1 is 4. 8 times negative 1 is negative 8 minus 1. 4 plus negative 8, or 4 minus 8, is negative 4 minus 1, which equals a negative 5. So my y is negative 5. And last but not least, decide whether or not he is a max or a min if he's smiling or frowning.